In this lesson, we're going to cover a lot of ground. We'll talk about choosing the right UI patterns, laying out your screens, working with graphics and text, and a whole lot more. But before we get into all those really fun things, we'll first need to learn about one of the core aspects of Android design, that your designs must work on a lot of often very different devices. Android runs on all types of things, from tiny watches to phones and tablets, even to cars and TVs. This variety can be daunting. The good news is that Android has been designed to handle this variety in device types from day one. The platform gives you a whole bunch of tools and techniques for handling different devices easily and gracefully. Your goal should be to create a single app that runs across a range of devices, adapting the interface depending on what device it's currently running on. As we'll find out throughout the course, optimizing the user experience across a variety of device screens and form factors isn't that difficult and can actually be pretty fun. Let's start by talking about the screens and all these different devices. At the end of the day, what good is designing beautiful buttons, text, and graphics unless you understand the screens they'll be shown on, right? When thinking about the variety of screens your app will run on, it can be tempting to look at the screen's resolution. That's the number of pixels on the screen. Screen resolution is a commonly used spec when buying a device, but it's actually not that useful when designing for Android, because thinking of screens in terms of pixels ignores the notion of physical size, which for touch devices is really important. When Android was first released, there was a single commercially available device, the T-Mobile G1. As a result, it was easy and often common practice to design with the resolution of this device in mind. Mobile designers accustomed to iOS, where there was only one form factor to design for, would apply those same practices to Android and design assets for one or two flagship devices with exact pixel sizes. These designs would look horrible when viewed on a device with different proportions. Android 1.6 Donut introduced support for more varied device types and densities, recognizing that generating pixel-perfect assets for every existing device doesn't scale, and that one would need a systematic way to deal with assets on different screens to better fit. Density-independent pixels allow the designer to create assets that appear in an expected way, no matter the resolution or density of the target device. A density-independent pixel is equal to 1 pixel at the baseline density, or 160 dpi. They're often abbreviated DIP or just DP. Don't confuse that with DPI, which stands for dots per inch. So what about at 320 dpi? This is often called 2x. Now at 320 dpi, 1 dip is equal to 2 pixels. So working with density-independent pixels helps you deal with crazy situations like this, where you may have two devices with the same pixel resolution but differing amounts of space. In this case, the tablet has a lot of space and the phone has a lot less, but they have the same pixel resolution. We'll see how density-independent pixels makes this much easier to work with. Now, because the tablet is at the baseline density, its physical and density-independent pixel sizes are the same, 1280 by 800. This phone, on the other hand, has a higher pixel density, so it has half as many density-independent pixels as physical pixels, so 400 by 640 density-independent pixels. Now, using density-independent pixels makes it easier to mentally picture that you have much more space on this tablet than you do on this phone. Similarly, if you have two devices with similar screen sizes but different pixel densities, one is, let's say, 800 by 1280 pixels and the other is 400 by 640 pixels, you might think that you have to design totally different layouts for the two of these devices. However, when you think of the screens in terms of density-independent pixels, they are the same size. They're both 400 by 640 dips. Now, this makes it a lot easier to make layout decisions. You don't have to design completely separate layouts. You basically just design once, and you'll kind of use the same layout across both of these types of screens. Let's try an exercise. Here's the 2012 version of the Nexus 7. The screen resolution in pixels is 1280 by 800. The density is 213 dpi, and the diagonal screen size is 7 inches. Now, using the conversion formula we looked at before, what's the resolution of the 2012 Nexus 7 in dips? So, using this formula, we can see that the Nexus 7's resolution in dips is about 960 by 600 dips. It's larger than a phone, which is about 360 dips wide, and smaller than a 10-inch tablet, which is about 800 dips wide. So you can see that this 600 value, this is the width when it's held in portrait, is neatly between this 360 dip wide phone and an 800 dip wide 10-inch tablet.